Hello, ladies and gentlemen. Welcome to my class, and I'm Steve Asikin. At this moment, I want to explain to you about the real-life reversing statistic. Yes, you hear that I want to talk from its tail, then go back to its head. Because normally, in real life, we only have limited amount of data. In this case, we only have 6, which is number of data, the correlation between those two, its average of the two, and also the standard deviation. From this 6 data we have, we must try to explain and we must try to discover all the 42 statistical identity of this data and what does it mean graphically. Let's try to count it one by one. This is the number of data, which is 60 because it's 5 years times 12 months. The average of the causes, let's say that is the promotion, let's do it for 100. And the affected variable, let's say that it has the average of 1000. We can assuming this like a sales. So it has the standard deviation, the 10 for 100 and 80 for 1000. And that both have 0.8 or 80% correlated. The total of x, it is normally reversing from the formula of the average. So the n times the average, we have the result of 60 times 100, this one, 6000. For the y, we do the same thing, 60 times 1000, it is 60,000. Then we try to start by squaring the deviation. If we square the deviation, we can come to the variance. So just squaring both two, we can know the two variances of the causing data and also for the effective data. We can also try to find sum of square deviation, because normally what we compute that it has mean of square deviation. So if we try to multiply the n back to the mean of square deviation, we can get the sum of square deviation. By this we have the sum of square deviation of x, which is normally 60 times 100 and 60 times 6400 for the y. For the whole row x b squared and then add it all together, we can compute that by reversing the formula of sum of square deviation, which is normally we added the sum of x multiplied by sum of x divided by n, we add back to the sum of square deviation. So we can find the sum of square deviation for the x and y here. So that is the first step, the beginning of understanding our statistic here. At least we already know 1, 2, 3, 4, 5, 6, 7, 8 data here, from the simple one up to the semi, which is a little bit more difficult. When we try to move on this next step, we can find the covariance by reversing the formula of correlation. So we multiply back the standard deviation of x and y to the correlation, then we can find the determination, the covariance. So if we try to multiply back those two, standard deviation to the correlation, we can find back the delta or the covariance. Then the sum of deviation of x multiplied by deviation of y, we can try to get it back by using the reversing formula by correlation is this number divided by the n. So by multiplying the n to the covariance, we can get the sum of the x deviation multiplied by the y deviation. So we multiply the n back to the covariance and we can get the total small x multiplied by small y. For the big x multiplied by big y, we can also go back from this formula, because we already know the multiplication of small x to the small y. Then by adding them back to the total x and total y divided by n, we can find the total x times y, which is, at this case, it's 6,384,000. So between the two data, we can compare the variance, which is normally in the Fisher's-ANOVA analysis of variance. We normally put the bigger variance divided by the smaller variance, and in this case, it's y divided by x, it's 64, because 6,400 divided by 100. Then for the determination, it is dominance. Normally, it's simply the square of correlation. If you have 0.8 and multiply it by 0.8, you have 0.64 as your determination. Then for the regression of possibilities, you can put the determination multiplied by the average of y divided by the rest of the determination multiplied by the number of data deducted by the number of variance, which is normally 2, x and y. So because this is, it means only 2, 60 deducted by 2, it becomes 58. So for this number we compute, it becomes 0.64 to 1000 or 640 divided by 0.36 and divided again by 58, so it becomes 30.65. After that, we can go to another step, which is normally talking about the graphic here. How can we compute the slopes or the tangents of the regression, and also the intercept, which is normally the regression are touching when it comes to the vertical axis there. The coefficient of regression or elasticity we can find by dividing the multiplication of the deviation by the square of the causing deviation, which is normally in total, both total becoming 348,000 divided by 6,000 is 64. After we know that, we can also compute the intercept. For the intercept, it is simple. The average of y eliminated by the slopes times the average of x. In this case, it becomes 360. Then we try to find the standard deviation of alpha, or standard deviation of the intercept. Because normally it is, we estimate like this, but it is some probability that it is not there. It becomes a little bit higher, a little bit lower, much higher, much lower, and normally this was spread in normal curve distribution. So that becomes normal distribution curve, which is normally the probability of alpha is determined like that. So we compute the first one. It is normally the average, the sum of y deviation divided by degree of freedom, and we can find 81.37. So it becoming multiplied by 1, 2, 3, 4, added to the alpha, and it also can be deducted 1, 2, 3, 4, deducted to the alpha. So the alpha or the intercept will be valued between 1 deviation to 1 deviation negative to 1 deviation positive, to negative to 2 positive, 3 negative to 2 positive, 4 negative to 4 positive, being the normal distribution. Between the 1 sigma it is 68%, 2 sigma is 95%, 3 sigma is 99%, and 99.99 for the 4th sigma. Then we can compute the last one, which is normally standard deviation of the intercept here, which is normally the changes in the slope because of the deviation. So this will be a square root of the square of standard deviation of alpha divided by the total square deviation of the x, and it resulting 1.05. So it becomes adding 1, 2, 3, 4 times to the average of 64, and can be deducted 1, 2, 3, 4 times to 64, and we have the data between 1 standard deviation, 2 standard deviations, 3 standard deviation, and 4 standard deviation as the probability according to the normal distribution. So in simple, we can say for the X data, the Gaussian data, we have the average of 100 out of 60 data. For the Y, we have the average of 1000 out of 60 data. Then for the alpha, we have the average of 360 for 60 data, which is normally here we can find it's about corrected by 81.37, and here it is corrected by 1.05, sorry, 1.05. So this is all the distribution possible for the data. Then for rehearse auditing, we only have 6 data here, and we try to explain that in 42 statistical identity, and this is the graphic we can draw out of the 6 data, and hopefully you can learn it. If you don't understand it now, just keep it, and then you can run again, see again the video, try to repeat that slower, step by step, and you try to find the multiplication of the number and the correct computation of this, then you can understand the statistic easily. Thank you.